Hello and welcome back. Previously, we were starting to discuss how we can use modules and other libraries to work efficiently with our code and also use external functionality to develop that is developed by others to enhance our own capabilities. One of the key things that we will come across is visualization. And one of the most fundamental visualization packages in Python is Matplotlib, and there are other packages like Seaborn that build on these foundations, or others like Plotly that take a different approach. The most common convention to include Matplotlib in Seaborn is the following: import Matplotlib as pyplot as POT. Maybe we can also want to import the whole library, but normally we don't really need to use this, and import Seaborn as SNS. As before, these are really conventions and you're not forced to use them, but almost everybody else uses them. So if you come across code that uses PLT or SMS, that almost always means that they use Matplotlib or Seaborn. If we work with Jupyter Notebooks, we can also use the following magic function, %matplotlib inline, to show the graph of our visualization in the notebook itself. Both libraries are very complex and allow us to customize plots and visualizations in a number of ways. And because they're very complex, it's helpful to have some sort of cheat sheet open that helps us to remember the most frequently used options. As an example, we now create a plot that shows a simple sinus oscillation and save the resulting figure. So to do this, we need the following steps. We create the x and y values. This is the data we want to plot. Create a figure as a Matplotlib object where we add all those data points. And then we add the data to this figure and add labels to the x and y axis as well as a legend to have a nice figure, and then save it finally. So first of all, we need to create the data we want to plot. Typically, when you use your scientific data, you will already have captured these data from some sort of measurement. Here we want to do this as a simple example. So we need to define the range where we want to define the data, and we can use the linspace function from NumPy to create an array of values. So we want to do this from -pi to pi, and here we don't define pi ourselves, but we use the definition as part of the NumPy package, and we use 100 data points. We don't want to use infinitely many. We have to specify the x and y value pairs we want to have. So this is our array of x values. And then for the y values, we want to evaluate the sign function, and we use nvSign for this, and pass the whole x object to it, and we return a y, which has the same dimensionality as x, and this defines our pair of x and y points. Now, in the next step, we need to set up the figure as a Matplotlib object. Especially when we work with Jupyter Notebooks, it's helpful to clear the figure, even if we don't think it exists yet, just to make sure that we don't accidentally work with an object that was created previously. Now we create a new figure, and in the simplest case here, we only have one figure to show, but we can, at least in principle, add a grid of multiple figures, but we don't deal with that complexity quite yet. We already know that the Matplotlib syntax isn't always obvious, shall we say, so we need to add some boilerplate code here, and then we can reuse this in our own work later as a template. And after this, we plot our data, add the access labels, and print it out to a file. There are a lot more plotting options in the Matplotlib documentation. So first of all, we clear everything that we have. PLT, remember, is pyplot for Matplotlib. CLF means clear figure. Now we define a new figure, that is PLT for Matplotlib, a new figure, and we give it the size, and this is our figure object. And then we add some subplots. We really only have one subplot here, and this is indicated by the 111. And we also move it around a bit and adjust the tick marks and the label size to make it a bit nicer. Then the axis labels are often cut off, so we need to readjust this. As we said before, it's not the most obvious of syntax and things, and this is also one of the reasons why packages like Seaborn exist, to take away a lot of these boilerplate. But now that we define it here, you can also reuse this in your code. Now this is the function where the actual magic happens. We plot the data, x and y, that we have defined previously, use red as a color for the plot, and add a label to it. Note that we need to not just co-plot, but we add this to the axis. It's a bit counterintuitive, but this is how we add the plot. We also add the labels for X and Y and give it font size. And we also limit the range of the data that is shown. Finally, we add the legend. This is done to the matplotlib object. And then add the title to the plot. And confusingly, this is done for the axis. In the end, we need to call plt show. And here fig savefig creates a file with this. As you can see, there's a lot of possibilities where we can get things slightly wrong and use different types of axis figures and the matplotlib object and confusingly add different parts to it. So this is really where we either need this boilerplate or use a different library. But at the end of the day, we get our sinusoidal function. As an exercise, do the same thing. Add cosine function to this plot so it looks like this afterwards. Now let's do the same in Seaborn. This is a bit easier, right? Because for such a relatively simple plot, it doesn't really help us if we have all this boilerplate. So we make the same thing a bit easier. Now we do the same thing in Seaborn. We do the line plot, add the labels and the title, and it's a lot less. And we can see that we already get a nice looking plot only for these with these few lines. And this is one of the advantages of using Seaborn, because it's defining a lot of sensible presets and defaults. If we only have a few data points, we may also want to add markers to highlight each data point. Let us assume that the sign function would only be evaluated at 15 points instead of 100. So we use the linspace, and instead of 100, we have 15 here. And then we do the same thing again. But now we add the markers equals true, and add the symbol we want to use. The little O signifies the filled little dot here. And here we can see where the function was evaluated, and by default, Seaborn adds a straight line between them.